The final section covers what's called relations, and really a relation is any set of ordered pairs. Doesn't matter if we have a set of ordered pairs, it is a relation. What we pay attention to is the vertical line test. This only shows up on the graph. But if you have a function and only a function, you can draw a vertical line on the graph and only cross through the function one time. If it passes through the function more than once, then it is not a function. It is instead a relation. So here are a few examples of relations that are not functions. If you look at this first one, if I input a 1, I could output a 0 or a 2. Automatically not a function. One input value cannot yield two separate output values. I input a 2, I output a 1 and a 3. Again, with one input value, I cannot get two output values in order to be a function. And then the final one, if I input a 3, I output a 2 and a 4. Once again, I cannot input one number and get two separate numbers. On a table, it looks like this. My domain value is 1, and it gives me two different range values. Domain value is 2, gives me two different range values. Domain value is 3, it gives me two different range values. If I plot the points on a graph, here we can do the vertical line test. If I draw a line, it goes through 2 points. Goes through 2 points, goes through 2 points. It cannot be a function because it passes through this set of coordinates more than once. All right, state the domain, state the range. So domain. 1, 2, 3, 4. Range. I'm going to list these values smallest to largest. 1 is a range value. 2 is also a range value. There are no other range values. So the question becomes, is it a function or not? Well, if 1 is my input, what is my output? It is 2. Are there any other outputs for 1? There are not. What if I input 2? Are there any outputs? 2 is an output. Anything else? If there are not, we're okay. Keep moving on. If I input 3, my output is 1. There are no other outputs for 3. If I input 4, the output is 1. There are no other outputs. So in this case, this is a function. Okay, state the domain and the range. Tell if the relation is a function. Domain, 1 and 2. Range, 3 and 4. So now we need to figure out if it's a function. If I input 1, I output 3, and I output 4. Automatically, this is not a function because there are two outputs for this single input value. So I can immediately say this is not a function. Here we're given a graph. State the domain, state the range, tell if it's a function. Well, the input values start here at -2. And this connecting line means that it's all the values between -2 and 0, and from 0 to +2. And then as we move up, this x value is still +2. So the domain in this case is from -2 to +2. If you notice, these circles are closed circles, so we include those points. The range, the lowest y value is 0, and this arrow here means that it goes on indefinitely. So for the range, y is greater than or equal to 0. So the next question is it a function? Well, if I start drawing vertical lines along this function, I notice once I get here, I'm drawing straight along this vertical line. This is an infinite number of points. A function only crosses a vertical line in one point. So an infinite number of points means this is not a function. Last two are a little bit tricky because they're absolute values. So I'll start with the first one. Domain. What am I allowed to put in for x? Well, I'm allowed to put in any number that I want. So in this case, the domain is all real numbers. So if I do that, what outputs will I get for y? Well, what values is y allowed to equal? Well, in this case, the range is also all real numbers. So then the question is this a function? Well, if I put in a +1 for x, what would y have to equal? Well, y could equal +1 or -1. That piece of information right there means that this big X, not a function. Let's try the next problem. What values am I allowed to put in for x? Well, it's a fraction, so I'm actually restricted on my values for x. And the truth is, the only number that you cannot have in the denominator of a fraction is 0. So here you would say, well, x cannot equal 0. So then the question becomes, well, what's our range going to be? Well, we know because of this absolute value, it can't be negative. And we also know that because our variables in the denominator, it can never be equal to 0. So for this one, our range is that y has to be greater than 0. Our function will be greater than 0. So the question is it a function or not? Well, if I put in a -1 for x, what will come out for y? +1. Will anything else come out for y? No, it will not. Let's try something different. What if I put in 100 in place of x? What will come out for y? 0.01. Will there be anything else? There will not. What we can conclude is that this is a function.